If you imagine any charged object, it will always create its own electric field that stretches all the way around it in every direction, very much like how masses produce gravitational fields or how magnets generate magnetic fields around them. To understand why this is significant, let's picture two tiny particles, one carrying a positive charge and the other carrying a negative charge. Although in reality these electric fields are spread out in all directions like invisible zones of influence, in physics we represent them using field lines. These are simple lines drawn with arrows, and the arrows always point from positive to negative, meaning they radiate outward from the positive particle and inward toward the negative particle. A crucial detail to remember when drawing these field lines, especially in exams, is that they should be drawn at right angles, perpendicular to the surface of the particle, not at weird slanted angles, and it's good practice to show a decent number of lines around the object, such as 8 lines evenly spaced, like shown in many diagrams. Another important point is that the strength of the electric field is not constant. It's strongest very close to the charged particle and it gets progressively weaker as you move further away, which means that when two charged particles come closer together, their electric fields begin to interact more strongly. If the two particles have opposite charges, like the ones we imagined here, there will be an attractive force between them, known as the electrostatic force or specifically electrostatic attraction, and you can actually visualize this by drawing the field lines from the positive particle stretching directly toward the negative particle, always respecting the direction of positive to negative. However, if instead we had two particles with the same type of charge, like two positives or two negatives, the situation changes completely because now the particles would experience a repulsive force, pushing them apart, following the basic rule that like charges repel each other. One more fascinating thing to understand about electric fields is how they interact with air. If we have an object that is highly charged, say a piece of metal that's been given a massive static charge, it would create a very strong electric field all around itself, while the nearby air particles, which are normally neutral, would initially act as an electrical insulator and prevent any electricity from flowing through the air. However, when the electric field around the charged object becomes strong enough, it can actually force nearby air molecules to lose electrons and become positively charged ions, a process called ionisation. And once the air has been ionized like this, it suddenly becomes a conductor, allowing electric charge to travel through it. This is exactly how sparks are able to jump across gaps between charged objects, moving straight through what was previously insulating air, and it's why high static charges can sometimes look like lightning in miniature. Anyway, that's everything for today's video. So if you found it useful, then do give us a like, share it with friends, and subscribe for more. We'll see you soon.